An operating system is the control plane that decides which identity can start a process, open a file, bind a port, load a driver, change a service, or read a secret. That makes hardening a systems engineering problem, not a pile of random settings. In this CipherVibe whiteboard, we build one model for Linux and Windows. We map identities to privilege, processes to services, listeners to exposure, patches to change risk, and logs to evidence. We will use command lines safely to inspect users, services, sockets, permissions, updates, firewalls, and audit events. The goal is a repeatable loop: define an approved baseline, observe actual state, make the smallest authorized change, verify the result, and preserve evidence. We also expose the failure patterns: blind hardening, copied commands, disabled controls, permanent administrator access, and recovery that was never tested. We finish with a checklist for servers, workstations, and cloud images. Start by drawing the layers. Hardware, firmware, and the boot chain establish the first trust decision. The kernel controls memory, processes, devices, file systems, networking, and security boundaries. Kernel compromise can invalidate protections above it. User space contains services, applications, shells, management agents, and security tools. Each process runs with an identity, permissions, credentials, open handles, and network connections. Linux combines user and group identifiers, permissions, access control lists, capabilities, and mandatory controls, such as SELinux or AppArmor. Windows uses security identifiers, access tokens, privileges, access control entries, service identities, and controls such as app control and defender. The shared question is, what can this process do if exploited? Mark trust boundaries around boot, the kernel, credential stores, administrative interfaces, update sources, and untrusted service inputs. Then mark dependencies. A hardened application can still rely on an overprivileged account or writable startup path. Start with mission, sensitivity, threat, uptime, and recovery, not settings. The safest unnecessary component is the one never installed. Begin from a supported minimal image. Inventory packages, features, drivers, services, startup entries, scheduled tasks, local accounts, remote tools, and listeners. For each component, record its purpose, owner, privilege, exposure, update source, and failure impact. Investigate before removing an unknown component. Hidden dependencies often appear during outages. On Linux, systemtool reveals service state, SS shows listening sockets, and the supported package manager exposes installed and pending software. On Windows, get service, get scheduled task, get net TCP connection, get net firewall profile, and get hotfix provide an observation layer. Compare reality with an approved baseline. Use vendor guidance, but never apply a benchmark blindly. Tailor it, document exceptions, test the workload, and verify rollback. The decision is required or unnecessary. Constrain and monitor what is required. Remove what is not through change control. Then continuously detect drift after deployments, patches, troubleshooting, and emergency changes. Compromise becomes serious when an attacker obtains durable privilege. Separate ordinary work from administration. Use named accounts, strong authentication, and dedicated admin workstations for high-impact systems. Shared root or administrator credentials destroy accountability. On Linux, sudo can authorize specific commands and record elevation. Review privileged groups, SSH keys, login shells, stale users, and unexpected user identifier 0. Capabilities can grant a narrow kernel privilege without full root, but they still require review. On Windows, user account control separates standard work from elevation. Review local administrators, powerful user rights, service logons, remote management groups, and stored credentials. Service identities need owners, minimum file, registry, network, database, and secret access, plus automatic rotation where supported. Never solve a permission error by making the application root, local system, or domain admin. That turns one missing permission into a catastrophic blast radius. Protect break glass access separately and monitor every use. The design target is temporary elevation, narrow scope, strong attribution, and rapid revocation. Trace one service from executable to network. Its executable, configuration, startup definition, libraries, secrets, and logs should not be writable by the account that consumes them unless required. Otherwise, service compromise can become persistence or elevation. On Linux, inspect ownership, permissions, access control lists, set user ID files, capabilities, writable systemd paths, and secrets in environment variables or shell history. SELinux and AppArmor add mandatory policy beyond ownership. Do not disable enforcement because a denial appears. Investigate, correct the legitimate path or policy, and test. On Windows, inspect file and registry access lists, service paths and permissions, scheduled tasks, autoruns, and PowerShell governance. Use Defender, attack surface reduction, application control, credential protections, and tamper protection according to risk. Bind services only to required interfaces. Keep the host firewall enabled even behind a network firewall, and permit only necessary sources and management paths. Every listener needs an owner, patch path, authentication model, log source, and business reason. Command lines turn intent into repeatable state. That power demands discipline. Confirm the host, identity, directory, target set, and current state. Read the full command. Preview changes when a dry run exists. Use explicit targets. Capture output and exit status. Verify afterward. Never paste an opaque command into an elevated shell. Do not download content and immediately pipe it into Bash or PowerShell. Retrieve from a trusted source, verify it, inspect it, and run with minimum privilege. Use signed Linux repositories and supported package managers. On Windows, use supported servicing channels and controlled update rings. Include firmware, drivers, applications, runtimes, and agents. Prioritize with active exploitation, exposure, criticality, privilege impact, vendor guidance, and compensating controls, not score alone. Use canaries, staged rollout, health checks, maintenance windows, and tested rollback. Emergency patches still require authorization and evidence. A secure administrator can explain the intended change, affected systems, validation, failure mode, and recovery path before pressing enter. A hardened host still needs detection and recovery. Collect authentication, elevation, account changes, process creation where proportionate, service and task changes, persistence, firewall changes, software installation, remote access, and control tampering. Linux may combine the system journal, authentication logs, audit, endpoint telemetry, and application logs. Windows provides event channels, PowerShell logs, Defender signals, and firewall events. Synchronize time, forward important evidence off host, restrict access, protect integrity, set retention, and monitor collection gaps. If an attacker can erase the only copy, the design failed. Baseline normal processes, service accounts, login sources, administration windows, and listeners. Alert on a new privileged account, a service launched from a user-writable path, an unexpected scheduled task, disabled security tools, or remote administration from a new source. Keep protected backups and trusted build artifacts outside the host's ordinary administrative boundary. Test restoration, keys, configuration, and identity recovery. During incidents, preserve evidence when appropriate. Rebuilding from known good state can restore confidence if recovery has actually been tested. Finish with the checklist. Define purpose, owner, sensitivity, exposure, availability, and recovery. Use a supported minimal image and a tested baseline. Inventory identities, packages, drivers, services, tasks, startup paths, listeners, firewall rules, secrets, and agents. Remove what is unnecessary. Separate normal work from administration. Use strong authentication, named accounts, least privilege, temporary elevation, protected service credentials, and monitored break glass access. Protect executables, configuration, registries, startup definitions, secrets, and logs. Use SELinux or AppArmor on Linux and supported Defender, application control, credential, and attack surface controls on Windows. Keep host firewalls enabled. Patch every software layer from trusted sources. Stage changes, verify health, track reboots, and test rollback. Before every command, confirm host and identity, understand the action, scope targets, preview, use minimum privilege, record, and verify. Centralize useful events, detect drift, and alert on privilege, persistence, and control tampering. Finally, restore a host and prove it matches the baseline. Avoid blind baselines, permanent admin, mystery services, disabled controls, untested updates, local-only logs, and reachable backups. Hardening is a loop. Define, minimize, constrain, patch, observe, verify, recover. Copyright 2026 CipherVibe. All rights reserved.